Hello everyone, and today is the day 19th of December, but we skipped few days, so I will be starting from the day 15, and we will actually run a couple of streams after this one, so each day is a separate video. Let's go and see what we have today. Some map again. There are a lot of maps on this year, during this year, so I have prepared all the files, and also I have enabled, I have paid for O1 Pro mode. We could try if models will struggle with these tasks, if O1 Mini will struggle with some of these tasks, we will try O1 Pro. So we'll see. Let's start from reading the description.
You appear back inside your own mini-submarine. Each historian drives their mini-submarine in a different direction. Maybe the chief has his own submarine down here somewhere as well. You look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini-submarine over to see if you can help.
Okay, we need to help who? The lanternfish, okay.
Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies.
So they have robots that help them, and some of the robots is running some amok, pushing around boxes. So what should we do with that robot?
Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot, so they could shut it off. However, if you could anticipate the robot's movements, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of movements the robot will attempt to make, your puzzle input. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict.
Okay, so the robot is again moving through the map, and there are boxes, but the boxes themselves are moving too. So what we have probably a map of these of the robot. Robot is at sign. So the boxes are O's, and the robot will also attempt. Well, let's read it.
As the robot attempts to move, if there are any boxes, O in the way, the robot will also attempt to push those boxes. However, if this action would cause the robot or a box to move into a wall, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you.
Initial positions. Okay, those are initial positions, the boxes, and the robot will move the boxes until it reaches the wall, apparently. Let's go.
The rest of the document describes the moves, it's for up, V for down, for left, for right, that the robot will attempt to make in order. The moves form a single giant sequence. They are broken into multiple lines just to make copy-pasting easier. New lines within the move sequence should be ignored. Here is a smaller example to get started.
Okay, so it's a smaller example. The moves. I'm not sure how the moves. So should the robot move until it and the box reaches the wall, and then turn? So the robot will attempt the given sequence of moves, and it will push around the boxes as follows. So it should go to the left, so it just stays near the wall. Then it should go up. It should go there. Okay, we have this one. So move left, move up again, move right. We are pushing the box towards the another box. Then move again right, and then we are able to push both of those boxes towards the wall. Then again right, we don't do anything because we are stuck. Then we go down. Robot just will go down, but there is a possibility to move over there for all the boxes, so it's able to shift them all. Then again down, then nothing. Then left goes again to the wall, or only one move. Yeah, just one move. It goes only one move towards the left, then down, then right again. Okay, I see now. So the large example has many more moves. After the robots had finished those moves, the warehouse would look like this. Okay, yeah, that seems okay. The lanternfish, let's read this.
The lanternfish use their own custom goods positioning system, GPS for short, to track the locations of the boxes. The GPS coordinate of a box is equal to 100 times its distance from the top edge of the map plus its distance from the left edge of the map. This process does not stop at wall tiles, measure all the way to the edges of the map. So, the box shown below has a distance of 1 from the top edge of the map and 4 from the left edge of the map, resulting in a GPS coordinate of
100 multiplied by 1 plus 4, so equals to 104. The box shown in below in this example. So we have 4 moves towards the left, and they're just so on the x-axis we go and multiply this by 1, so we get just 4, and from the along the y-axis we multiply each move by 4, or by 100, and then we sum them up. No problem. Okay.
The lanternfish would like to know the sum of all boxes' GPS coordinates after the robot finishes moving.
Okay.
In the larger example, the sum of all boxes' GPS coordinates is 192. In the smaller example, the sum is 2028. Predict the motion of the robot and boxes in the warehouse.
So it's
after the robot is finished moving, what is the sum of all boxes' GPS coordinates?
It's pretty straightforward. Let's go on. By the way, I have always what I did. I've attached README file, but it's like I have a thing called cursor instructions or something. Instead of attaching README every time, how does it work? How does it work? Let's see. So let's use our search, cursor instructions dot file cursor or something. I'll make you see that. Sorry, one moment. So in cursor ID you can customize AIs with cursor rules file. This file placed in your project root directory allows you to define project specific instructions that guide. Okay, so like we can create the cursor rules file instead of README, or just like copy the same thing. Yeah. So now we have this cursor rules. We will go to the O1 mini and let's write. Let's select O1 mini. So now I basically I can skip attaching readme file every time. Let's firstly get our puzzle input and place it to the input.txt. Then we'll copy our first task description and we'll see how O1 mini will solve this. So solve the first part. We'll add O1 mini day 15 file, and yeah, okay. So we could actually try it O1, but I'd like to firstly try O1 mini. So what is the solution? We have a warehouse map, robot position boxes, for Y row in enumerate warehouse map, X and cell. Okay, so we get for each cell. So basically what we are doing now, we have a set of coordinates of all the boxes, and also we set the initial robot position. Then we will do what? Moves. We get all the moves, move directions. For moving moves, dydx, we get h move. We are detecting like the changes in the for each of the move sign. Then we are calculating next robot move. Then what we are doing, warehouse map, new robot position. So if it's a wall, if new robot position is a wall, so we are blocked. Then if new robot position in boxes, then new robot position, new box position is new robot position plus dy, new robot position plus dx. So it means that it will displace the box, the adjacent block box, to the new position in the same direction. But if warehouse map, so if this new position again, recalculated one, is a wall or new box position, this coordinate is contained, like this coordinate in xy axis is contained inside boxes set, then we continue doing the same thing. We go back, we recalculate the new box position. Seems fine. Hopefully it will solve it correctly. So we'll run Python solutions. I need to go inside the solutions file, solutions, and Python O1 mini. Okay, we get our number, and let's see if that's correct. Okay, no, it's too high. All right, so something is not correct here. We'll get another chance to the. We'll get O1 mini another chance, but let's try O1. Since I have now the O1 Pro mode, we can just try it anyway. It will take some time, so just let's start from O1. Also need to include the cursor rules. And our file template. O1 mini. So the first part, using this template, and let it think for some time. Interestingly, that I'm surprised that O1 mini wasn't able to solve the first part. Even the logic was quite correct from the first glance. So we have a reading input, but separate map for the moves. Try a full map boundaries. Okay. If we didn't break from the loop, so okay. If the map heuristic, if the map lines are consistent, well, just assume all contiguous lines equal length of map. Okay, your main lines after the map are moved. Okay, we get our robot position boxes. Then very close to what we had before. So helper function to check if the cell was a wall. Nice one. Move and moves. Okay, check if it's a wall. Continue. If no robot is in boxes, then we apparently move the boxes position. If the wall. Okay, so we got something. Let's run it, and it will be 01. 01. We got another number, and it's smaller. Okay, so there was a problem with 01 mini solution, but a very tiny problem. Yeah, 1 gold star perfectly. So 01 solved this. We got our second part. Let's firstly read it, and then we'll move to prompting all other models.
The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, reports start coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There is one key difference. Everything except the robot is twice as wide. The robot's list of movements doesn't change. To get the wider warehouse's map, start with your original map, and for each tile, make the following changes.
So the following changes are: if the tile is wall, then the new map contains wall instead. Like where? It's a Y. It's in X direction. Extends to the X direction. And I assume now. So no, it is still like. I thought it would be not a rectangle, but apparently it's a rectangle still. Okay, anyway, if the tile is a hashtag, the new map contains 2 hashtags. If the tile is 0 or O, the new map contains this thing. Oh, it's like a box. Okay, if the tile is dot, then new map contains 2 dots. If tile is at, new map contains at dot. Okay. Okay, we just need to firstly do the conversion from our map to another map. Because boxes are now twice as wide, but the robot is still the same size and speed, the boxes can be aligned such as they directly push 2 other boxes at once. What? So consider this situation, and we go left. So after appropriately resizing this map, the robot will push around these boxes as follows. Ah, okay, I see now. So it like previously we moved 2 boxes, and the first box would get the same position as the box down below. So if we moved those 2, this O box will be aligned on the y-axis with the bottom one. But now it's in the middle, like in the middle of both of them. And yeah, okay, so what? Okay, so the robot is able to, not just able, it always is placed near the corner of the boxes. And now, apparently, the situation is harder because we could have those complex situations where the robot is trying to push this box, but we get a wall not in front of those of the boxes, but slightly to the left or to the right, and apparently they shouldn't be moving. Yeah, that's what happened. None of the boxes have moved, or has. So we move left, we move left, we move up, and then we are able to move only one box. Okay, this is a trickier problem. So let's read another condition.
This warehouse also uses GPS to locate the boxes. For these larger boxes, distances are measured from the edge of the map to the closest edge of the box in question. So, the box shown below has a distance of 1 from the top edge of the map and 5 from the left edge of the map, resulting in a GPS coordinate of...
Okay, because we have different sizes of the box, different size of the box, of the boxes. Now we are calculating from the left edge of the box. No, from the edge of the map, but closest edge of the box. When would it be? Like if the box is aligned with the wall, what do we do? Which edge? Probably the left edge, so it will be always the left edge is closer. So in this scaled up version of the larger example, after robot has finished all the moves, the warehouse would look like this. Okay. And yeah, let's prompt our O1 model as well. Again, the full task. Full description. Where does it stop? Okay, so here we need to also remove our answer for the first part, so the model won't be confused. Okay, first puzzle is complete. I remove the answer, and now solve both parts using this template. And let's start with O1. Then we'll go to O1 mini and place the same thing. Yeah, and let's go continue and revert. So this is O1 mini. While it's thinking, we'll go to... Oh, by the way, O1 is already giving us something. Let's prompt Claude 3.5 Haiku. Let's start from this model. And yeah, O1 is still writing something. O1 mini is still thinking. Okay. Claude Haiku is writing, and yeah. Let's see which one finishes the first. Yeah, Haiku is finishing. And also O1 mini is giving us something. But let's run Haiku's code. Let's go to 3.5 Haiku. Let's see if everything is correct. Yeah. Okay, let's run. So Python Claude 3.5 Haiku. So we got an answer which is the same answer as O1 mini did the first time, which is interesting, but is not correct. Apparently, the second answer should be another as well. So I will just write the numbers for now here, and now we will see then which, like, this is failed. I'm not sure about this one. Okay, so O1 mini got us something. Let's go and run O1 mini code. And we have unexpected indent, which is unexpected. Okay. Why? There was some problem in applying this code. Let's see again. Part 1, solution for part 1. What? Oh, okay, so it's existing code. It should have solved both of the problems. Implemented part 2. Did I write solve only one? No, solve both parts using this template. Something is not correct. So I'll run again. So let's place the prompt and let's delete everything in this file and just let it run again. So Haiku fail probably for both, I think. Now let's do prompt Claude Sonnet. And let's see. So Claude Sonnet is writing something, parse map. Okay. So we got something again from the O1 mini, but for some reason only part 2 is updated with the implemented solution for both part 1 and part 2. Part 2 only. I don't see anything for part 1. Am I missing something? So part 1. Okay, my bad. Yeah, okay. Yeah, sorry guys. I need to place the actual template, not the one that contains the solution. And I need to rerun all the prompts. So let's go again, submit, revert, and let's see. I'll do the same thing for Claude Haiku, because apparently it got not the correct template. Again, same for O1. Let's just check for if I was. Yeah, I've included the solution here as well, which was incorrect. Yeah, let's go again. So both parts. Okay, let's start. Okay, so again, O1 thinking. Claude Haiku has written all the code. O1 mini is apparently finished. Yeah, part 1, part 2, parse input, scale warehouse, find robot, find boxes. I like the style of this code now. So again, O1 mini. We got 2 answers. And yeah, the same. The answer for the first one was which? The answer was 121, 151, and here we got 152, which is incorrect. 153. I'm not sure which. I'm not sure if that's a correct answer, but yeah, I'll just put it into the O1 mini. So still part 2 not sure. Part 1 is failed. For O1 mini failed to do this. Okay, let's see what O1 did us. Okay, is this the full code? Hopefully reference implementation. Okay, hopefully it's a full code. Let's test out the O1 model. O1 mini. Let's go. Can push now. Yeah, so probably there are no placeholders like it did sometime. What's that? object is not subscriptable. Okay. Okay, let's run O1. Okay, we got a different answer. The first one seems to be correct. 333. Yeah. Let's see for the second one. And it's too high. Okay, so O1 didn't solve this. Apparently, yeah, so I'm pretty sure Haiku won't solve this as well. Let's go with Haiku, Claude 3.5 Haiku. Yeah, nothing is correct at all. Haiku, failed. O1 mini, failed. Yeah, failed because answer was too high. It should be smaller. Then O1 preview, not preview now, is O1, which is success. Oh, success and failed. Failure. Anyway, so let's go with the Haiku. Sorry, Sonnet. Let's start new chart with Sonnet and let's go. Sonnet is writing. Now, what I will do now is to try O1 Pro mode and hopefully it will do that. Here we have another nice animation of the loading. And yeah, it would take some time, probably a couple of minutes. Sonnet is giving us something, and let's go with other models inside cursor. So let's go GPT-4o, let's select GPT-4o and let's prompt it in normal mode. Okay, it's giving us something. Claude Sonnet gave us as well. Let's go with Sonnet and let's run it. Sonnet. Wow. Some reason seems like it just stuck somewhere in a loop. No. Wow, so Claude Sonnet failed in this one as well, even in the first part. I would like to try another time with Claude Sonnet, because it's a really unexpected, and yeah, GPT-4o was kind of lazy today. No, this does not implement nothing. Okay, so both right, full solution. Okay, what we do have from Sonnet as well, again, let's go and replace this code. And yeah, let's see. Claude Sonnet, index out of range. Okay. For some reason, Claude was not able to parse. Okay, so we got an answer for the first part, which is incorrect. That's the result. Okay, so failed. For Claude Sonnet. Let's see what did GPT-4o. There's some code now. Part 1, expand map, calculate, remove robot. Part 2, where is part 1? Where is part 1? I didn't tell it solve both parts using this template, right? That solution. Okay, I'm pretty frustrated that I need to prompt this one more time. First part 1, then part 2, in the same file. Keep the logic separated. Okay, let's go to yeah, Sonnet failed. Bye bye Sonnet. Claude. Now we got our something solution. Our solution. Now we got nothing. Wow. O1 Pro mode. Just look at that. Below is reference solution based on the problem. Since puzzle text already gives the final answers, provide examples. Where? Didn't I remove it? Part 2? No, I did remove. No. Similar to part 2 real solution. No. Yeah, that's why when you pay $200 for the subscription, you would just expect that there will be no such things. So both by using this method, full code, full solution, our input is inside the file. The description contains only example inputs, not the real one. Okay, let's go again, and we need to wait some more time. Okay, let's see what GPT-4o get us. Again, part 1 we get, part 2 we get something. Transform map, simulate. Okay, the same thing, but yeah, I'm pretty sure it will fail. GPT-4o. Yeah, just not even giving us an answer for the first one. Key error. Okay, yeah. I'm tired of prompting GPT-4o. So, failure for you. Failed. Okay. So we tested. What did we? Didn't we test? GPT-4o mini. Yeah. Okay. So it'll probably fail. Mini for day 15. And select this model. And let's go. Okay, so now O1 is still calculating. We also have other models like Gemini. And let's copy the prompt. And let's go to Gemini. And let's ask it. The Gemini experimental 1206. Okay. For some reason it didn't even think about it, which is kinda frustrating as well. Okay. Maybe I should prompt it specifically to think before, to plan the solution before. But yeah, it's not what I'm testing. Alright. So, again, it doesn't understand that the task is... Okay. I'll do this again. First part, let's say keep the logic separated. Okay, so now we are including the description contains only example inputs, not the real one. Let's go again with the GPT-4o mini. Let's see what Gemini did get us. Let's place it into the code and let's run it. Okay, it failed to correctly place the input path. So let's run Gemini. Okay, failed answer for part 1, and let's see if the part 2 would be correct. No, it's too low. Okay. Too low. Oh. We got different answers for. Have I tried this one from 01? Yeah, probably. I have been trying this out too recently. Okay, I need to wait. Yeah, I think I've tried this one. So let's see. Part 1, part 2, grid, coordinates. What? Yeah, implementation details. Okay, accept. So now, nothing for GPT-4o mini. Failed. 01 mini, Gemini. Let's see. Okay, so Gemini. We had tried. Yeah, and failure for both of those. Okay, so our only hope will be 01 Pro. There's some code finally in there, and let's try it out. 01 Pro Python. Let's run 01 Pro, and the answer is the same. Yeah, well, at least it had part 1, but not part 2. Since no model has successfully had solved this one, I will prompt 01 Pro again. So what should I do? I'll copy this. I'll go try to submit this answer, and I will. Yeah, this is not the answer. The answer is too low. And also is the same as the first. Read the second part again and plan. What do you say? Plan thoroughly. Okay, let's try it again. Let's return and let's see. So yeah, 01 mini, GPT-4o mini failed. We got only one model left, which I haven't included in files, but I can just run it from DeepSeek chat. DeepThink, and yep. I don't think it will do anything, like solve anything, but yeah, at least we try. DeepSeek. Why? Let's see. So we get DeepSeek solution and 01 Pro. Okay, part 2, converting cell coordinates. What do you do? Okay, nothing. Like, at least DeepSeek thought about the problems. Gemini 1206, which is able to think, for some reason didn't. And DeepSeek is thinking, but the kind of thinking of this model is different. It's like it's not a smart model. It's like, I'd say, probably closer to O1 Mini. At many, in many like in many respects, like in many, and the thinking process is not hidden, and apparently it's just how would people think about the problem. Okay, it's planned approach, part 2, solution code, parse map, part 1. We do something, we move directions, movements, move the box, append, calculate, scale the map then. Part 2, we scale the map and probably do the same thing. Move directions, yeah. Alright, I see now. So probably all the models they cannot understand that if the boxes are like diagonally positioned, and the robot is trying to move the one which is blocked by another box, which is blocked by a wall, which is not in a straight line, then it couldn't move. Probably that's the problem. Yeah. So DeepSeek solution. Let's run it. Let's see. Okay. No problem. That's not an issue. Okay. Again, nothing. X is not placed. I won't be prompting it again. Just you should, if you're a smart model, you should be able to like think through those potential issues in your code, inside your code, in the logic that you're writing, and you shouldn't be having these problems, like those value errors at least. Yeah, there could be problem with your logic in terms of solving the task, but not like this. It's not about solving, it's just about understanding how the code is working. So no points for DeepSeek. I will, yeah, failed. Okay, so we now we get something from GPT for O1 Pro, and I'll give it another go. O1 Pro, yeah, we get another solution. I don't remember this number yet, but let's submit it. No, that's not right answer. Yeah, okay. So we need to wait another 5 minutes. In any case, with additional prompting, no model had solved the second part of the day 15. Okay. I will do once again with O1 Pro. So I'll close now. I won't close because we need need it for another day. But yeah, I'll be closing all these files except O1 Pro. Did I fill? Yeah, all the models. Okay, so those are the solutions. Again, for O1 Pro, the first one was solved correctly. Let's edit as well. O1 Pro success failed. Okay, yeah, that's correct. That's correct. But at least, yeah. So I'll prompt it additionally once more. I'll try to like not looking at the code. Just tell it like. You know, like, what do I say? See the edge and consider the edge case when the boxes are diagonally positioned in the part 2. And the one is that block, like one is that further away can be blocked by the wall. Therefore no boxes can be moved it's like is a single box and the edges are connected to the other boxes edges and I don't know what to say else. And just think about other edge cases. Okay, let's run it once again. And after that, if it fails or success, we will move to the next day. But I will turn off this stream and again I'll create another one. So just wait for the new stream. Yeah, let's see now. Could we? Yeah, we can enable details. Let's see how it's thinking. Ensuring precise movements, verifying functionality, ensuring accuracy. Okay, let me see the code correctly. Carefully avoids partial moves and boundary checks. If it gracefully handles diagonal boxes by restricting them vertical horizontal pushes. Okay, so I'll open up all the windows I have. So this is a DeepSeek new chat. We have some solution from O1 Pro again. And let's see whether it was correct. Again, let's run. Yeah, we just get the same answer. So, alright. Again, seems to be not a really tricky, like it's a tricky problem, but apparently even O1 Pro lacks some understanding of those movements of the boxes, or I lack prompting, like, not experience, but I should have prompted it better, or I should just understand how it could be solved and iterate on the solutions, on the solutions of O1 Pro. Yeah, and probably then we would be able to solve this one. Again, since the code is not correct for the part 2, I won't be I won't be trying to understand it. Yeah, alright, bad day for all the models for part 2. Good. Let's submit. Update readme like now. Hands result tracking day. Okay, add day 15 solutions with detailed implement robot movements. Okay. So, alright. Let's go to O1. Okay, we have DeepSeek. I will have another. Okay, Gemini. So I have O1, DeepSeek, and Gemini. Also, I need Claude. And yeah, that's it. Thank you for watching, and let's go to the next day, which is day 16th. See you on the next one.